flipping the coin, right? So we need to commit to a particular block number, and then we're going to check at some point later when that block has been mined whether the hash of the block, of that block whose number we committed to, was indeed, when modulo 2 was indeed 1. Okay. Everyone, that probably was about as clear as mud. Has anyone got any questions so far? Because this process is kind of intrinsic to the code I'm going to show you. No? Everyone feels that they understood?
So what do you do with the two numbers? Like, you have two parties, each party has a number, and you said they get XOR'd, or?
No. So this is where there's only one party.
Oh.
So there's one party and there's a contract. The contract doesn't count as a party because it only works deterministically.
Okay.
So we can't actually choose a random number. All we can do is decide on a particular event that we have absolute truth over in the future. And in that case, it's the hash of a block.
Okay.
Everyone happy so far? Yeah. Okay, good. So, our contract has a couple of events, staked and claimed. So staked just is an event that happens when someone places a stake, and claimed happens when someone tries to claim a stake that they placed. We have a ticket. I forgot to mention struct. Okay. There is another primitive in this language. It's called struct. Right? It's very similar to a C struct. It just holds a bunch of fields and it glues them together, and you can use it as a single thing. In this case, we have a notion of a ticket, right? So it's like a ticket stub. And you get it when you place a bet, and you can sort of claim it after the event, after the fact. So it's very, very similar to when you actually do it in real life. In this case, it's got two things. It's got the block number, so this is effectively like the block that we bet on, and also it's got this the stake. So how much did we bet? Yeah. And the way it's going to work is going to be a very nice contract. It's going to be sort of benevolent DAO. It's actually going to give us twice as much back if we won, and it's going to be 0 if we lost. So it's going to be the actual odds, as it should be. Okay, so we've got our two stages. The first stage is flip, and the second stage is claim. The only other thing we've got is this mapping. All that does. Okay, actually, let's go to flip first. So, in addition to the commit reveal process of the block, so betting on this future event, we're also going to make sure that the client feels very safe by allowing them to choose a random number themselves and commit that random number, and then tell us just the hash of it. So they committed because they're going to tell us the hash of this number, and if they give us a number whose the hash isn't that, then we're not going to honour it because they committed, right? They committed to saying that the thing that I'm keeping secret, or the hash of that, is this. Yeah. So they're going to record with us this hash as part of their commitment, and we're calling that the tag, right? So there's this idea of the key and the tag. The key is the thing that they keep secret, and the tag is the hash of that they're going to give to us as a way of committing to this key. Later on, we're actually going to combine the key with the future event to get our ultimate random number. So at this point, all we want to do is record the tag and however much they bet. Okay. Now, however much they bet is actually just the value of the message. It's however much ether they sent to this with this function call. The number, which is kind of like the event that they're betting on, well, we're just going to record that as the current block's number. Okay.
But we couldn't get the current block number.
We can get the current block number because that's just the last block number plus 1. What we can't get is the current block hash, which is what we're going to ask for in the second stage when we know it. Okay, so we've got we're going to call our event just to say, hey, someone staked something. There it is. It doesn't actually do anything in terms of altering the state of the contract, and that's it. Right? It's just a record. The second stage is claim. Now, I'll point out is that this is part of the state. So this is a mapping, and it's going to map from the tags. So these sort of stubs, the hashes of the key, the commitments, and it's going to map that to a ticket, which is what the commitment was for, which is to say the stake and the block number that it was bet on. So the second stage is claim. Now, it's very important that this can't claim sort of before the event has happened, yeah? Because the event that we're betting on is this is the hash of the block number of the block that has the current block number. We can't find that out until the block's been mined and we're into the next block. So it's very important that we first check that the block number, the current block number, is greater than the number that it was bet on. Actually, it should be greater than. The second thing that we're going to check is that there's actually something at stake, right? If they can't, there's no point going through all this if they've got nothing at stake. Okay, so once we're happy that they've got something at stake for this tag, and the event has happened, it's in the past, then we'll go through, and we're going to check whether they won. Okay, you'll notice tag wasn't passed in. At the point of claiming, they don't pass the tag anymore because they want to claim, so they have to give their secret, and that's the key. Okay, and we know that the tag should have the hash of the key. Because that was the thing. If it hasn't got a hash of the key, there'll be nothing in the tickets where we're looking for it, so it'll all be 0 and nothing will happen. So that's how we check that they're actually telling the truth about their commit. Okay, and then we just do this little XOR operation. This is the magic that combines their key, the thing that they were sort of their random number part of this, and the actual event, the block hash of that's a book. Very good at debugging code. I guess you guys are all my rubber ducks. So we've got block hash, and then we're going to use the number. So we're going to look up what the block hash was, combine it with the key, modulo by 2, because it's just a 50-50 thing, and check whether it's 1 or not. If it is 1, then we won. Yay. And we will do we'll send to the message, to the person who sent us the claim, we'll send them back twice the amount that they put at stake. If they lost, we're not going to send them anything. We'll also point out, we'll do an event that they won, and then we'll do some cleanup. We'll do an event that they claimed, and then we'll give, as part of the parameter of that event, whether or not they won. And then we'll do some cleanup, we'll delete the tickets. Delete the ticket that they had. We want to delete it because if we don't, they'll just pile up in storage, and that's bad for the blockchain.
They could double clear.
Also true. Also true. Now, what does the front end look like? So we've got these two things. These just set up the environment. We're also going to use a function. This is basically our way of creating a tag, right? Well, not a tag, a key. So this is the random thing, our random contribution to the end state. We're going to set up this new ticket thing. That's going to be a function. We're going to define it later on. We have in log stuff. That doesn't matter. And where are we? Tickets. Right, so tickets are the ongoing tickets. Okay? So we're going to keep track of all the tickets that we have, all the stubs, ready so that we can claim them when the block has been mined. We also have an update function, which is that, and a new ticket function. Take us through the new ticket function first. So the new ticket function, first we need to make a new key. Right? This is the thing that we keep secret. The contract doesn't know about that. If they knew about it, they might be able to fiddle the answer. I mean, they couldn't because it's based on the block hash. But if the contract owner was also the miner, then there's some vague potential for them to do it. So we create a key. We place the key in our tickets object, our JavaScript object, like a map. We remember the tag, which is actually just the SHA-3 of the key. We remember the amount that we bet. We don't really need to remember it, I guess, but why not? We remember the number that we bet on. We do this so that we know when it's time to claim, so that we know when the new block has been mined and we can go away. And we also remember the outcome so that we don't try and double claim stuff. That wouldn't, as long as we have the delete thing in the contract, we can't double claim, but we don't want to waste money trying to double claim. The next thing we do is we need to tell the contract, hey, we want to do this. We want to flip a coin. The way that we do that is we call the contract with a particular amount of value. Right, that's the amount that we want to bet, and we attach the value to the call just by using this dot value between the contract object and the actual function that we actually do want to call. That's how we denote it. Finally, we go into the function, we say flip, and we pass in our tag. This is the thing that the hash of the thing that we took a random, our key, our random secret. We then update. So what happens in update? So update does two things. The first thing it does is it actually updates the page with our current tickets and tells us whether we win or not. The second thing it does is it claims any tickets that are ready to be claimed. So firstly, we're just going to build up some content, and eventually we're going to put in the page wherever the bets thing is. We're going to put that content there. So we're going to shoehorn it into this div here. The next thing we're going to go through the tickets. If the outcome of the ticket is unknown, so which is to say if we haven't claimed it yet, and if the block number is greater than the number that we put the claim in, yeah. So basically, if that block has been mined, then we're good. We're good to go. We can claim it now, right? So we send it off, and it's very easy. The first thing we do